Hello and welcome. This is a webcast from Merck Millipore. Our webcast today is about very high performance liquid chromatography. All the results we will show were obtained using standard HPLC instruments operated at pressures below 400 bar. We will compare Merck Millipore's Chromolith HighResolution HPLC columns with core shell particulate columns. Chromolith high-resolution columns are made from one single piece of porous monolithic silica manufactured by a sol-gel process. Monolithic silica has a rigid bimodal pore structure composed of mesopores and macropores. The mesopores are located in the silica skeleton and they give the high surface area of the silica. The macropores are equivalent to the interstitial volume of particle-packed columns, and they give the monolithic column its very high permeability and porosity, resulting in very low column back pressure. The key benefit of low back pressure is that Chromolith high-resolution HPLC columns can give faster analysis than any comparable column. Further benefits include the possibility of increasing column length to obtain even higher resolution, the option of using flow gradients to optimize separation, and the ability to use more viscous organic solvents such as methanol or even isopropanol. When comparing different column types, Chromolith high-resolution provides the very high efficiency typical of small particle columns, while maintaining at the same time the low column back pressure normally associated with big particle-packed columns. That's the best of both worlds. In addition, they offer longer column lifetime and more robust analyses. Core shell columns also exhibit similar characteristics, but to a lesser extent. Now we compare data for core shell columns from two different manufacturers, the blue and the green curves, with data for Chromolith high-resolution columns in red. The HU and the PU graphs demonstrate that Chromolith high-resolution columns provide separations of similar efficiency to core shell, but with significantly lower column back pressure. This is further summarized in the separation impedance data shown in the EU curves. Here we compare selectivity data for tocopherols, antiepileptic drugs, catecholamines, and proteins. Column selectivity is virtually identical for Chromolith high-resolution columns and for core shell columns. Only minor variations in retention time are seen. However, again we see that column back pressure is more than 3 times lower for the Chromolith high-resolution column compared to core shell. The same is true with complex samples. This is a separation of 32 pesticides. The separation with Chromolith high-resolution is equal to or slightly better than with core shell columns, while back pressure here is almost 4 times lower. Now we can make our first summary. Chromolith high-resolution columns give faster high-performance separations when using HPLC instruments up to 400 bar pressure. In this example, the results with Chromolith are twice as fast as with core shell column and 3 times faster than core shell column K. Chromolith high-resolution columns can considerably increase sample throughput with standard HPLC instruments. In this chart, we investigate sample loading capacity. For accurate analysis of trace impurities, it is very important that high sample loading is possible. Here, hexabarbital was injected onto the columns with amounts up to 60 micrograms. Above 12 micrograms sample loading, the core shell columns were overloaded, and peak shapes were no longer acceptable. The limited loadability of these columns could make calibration and impurity or trace analysis inaccurate. Separation efficiency and peak resolution are also reduced. By contrast, Chromolith high-resolution columns were able to separate the compounds in sharp, symmetrical peaks even up to 60 micrograms, thereby demonstrating up to 4 times higher sample loadability. Finally, we investigate sample carryover. After injecting 10 matrix-rich biological samples onto a Chromolith high-resolution column, a blank gradient was run. As expected, the size of carryover peaks observed was negligible. Under the same conditions, both core shell columns displayed significant carryover peaks from previous injections during the blank gradient run. Such carryover effects can cause errors in the analysis results and are not acceptable in many quantitative applications, for example in pharmaceutical labs. To summarize, compared to core shell columns, Chromolith high-resolution columns offer the same high efficiency and very similar selectivity, faster analysis, lower column back pressure, higher sample loading, lower carryover effects, and longer column lifetime. All these benefits add up to greater productivity and efficiency at lower costs. In conclusion, Chromolith high-resolution columns are a very attractive alternative to core shell columns. They ensure that analyses are always performed at lower back pressure, with higher loadability, without significant carryover effects, and with longer column lifetime. For more information on how Chromolith high-resolution columns can help you solve analytical problems, please visit our website at www.merckmillipore.com Chromolith high-resolution, or simply send us a mail to chromatography@merckgroup.com.